All right, I want to next introduce you to Weiqing Chu. Weiqing is a second-year PhD student in ecology, evolution, and conservation biology. She earned her bachelor's degree from East China Normal University and her master's degree from New York University. Her research focuses on assessing species' vulnerability to climate change. In her free time, Weiqing enjoys listening to music and watching films, with a particular fondness for those from the 1980s. Her presentation is titled, "Why the Same Plant Thrives in One Place but Struggles in Another."
Climate change is not affecting all species equally. But here is something we often overlook. Even the same species may be vulnerable in one place, but relatively safe in another, because climate, landscapes, and history differ between regions. For example, in October 2023, sunflowers were blooming in Illinois, but in Pennsylvania, the same species looked stressed. In June 2020, multiflora rose thrived in New Jersey, but struggled under the heat in Texas. So my research asks a simple but important question. How does species sensitivity to climate change vary across space, and how can we use that information to make better conservation decisions? I used plants across the US as my study organisms and estimated their sensitivity in different regions based on two key important factors: how rare a species is geographically, and how wide a range of climate conditions it can tolerate. To do this, the Climate Adaptation Science Center Network, or CASC regions, were used. They were designed by grouping states into regions that share similar climates. Finally, I compared the spatial consistency of species sensitivity. So, what did I find? First, states within the same CASC region tend to agree on which species are more sensitive, but that agreement breaks down across regions. Second, geography matters. CASC regions that are closer or share similar latitude tend to show stronger similarity in species sensitivity. Furthermore, I found that species tend to be less sensitive in regions that are northern, mountainous, or shaped by past glaciation. Facing climate change, cooler temperatures at higher latitudes, higher elevations that offer cooler refuges, or evolutionary histories shaped by glacial cycles all help species cope better with variable climates. So why does this matter? Because conservation decisions are always made with limited resources. If sensitivity varies by region, then a one-size-fits-all strategy doesn't work. My results suggest that we can use CASC region as a regional framework to help prioritize the conservation of the most vulnerable species in each region. As climate change accelerates, knowing where species are most sensitive may be just as important as knowing which species are sensitive. Thank you.
So those images that you showed were really impactful. How do you think that your research could be used for conservation efforts?
Yes, that's a great question. Actually, the CASC network is an already very well-established system with established partnerships and also management structures that help wildlife to adapt to climate change. They're designed based on climatic consistency and state boundaries, which makes them practical for management. However, it hasn't been really clearly tested whether this kind of climate-based regionalization can actually reflect the biologically meaningful patterns of species sensitivity. So my research answers that question and suggests that conservation should be region-specific. Within each CASC region, we can identify a spectrum of species from the most to the least vulnerable, and based on their habitats, use that knowledge to help prioritize the most at-risk species and places. In this way, we can make sure that the resources are directed to where they are most needed.
That's fantastic. Thank you.